Namaskar and hello dear students. Today we are going to study chapter 14 of NCERT Chemistry Part 2 textbook, that is Environmental Chemistry. In this chapter we will understand the meaning of environmental chemistry, define atmospheric pollution and tropospheric pollution. Third, explain reasons for global warming and greenhouse effect. Fourth, identify causes for acid rain and smog formation. As you are already aware, environmental studies deal with all the social, economical, biological, physical and chemical interrelations with our surroundings. In the part of this, let us discuss environmental chemistry. Environmental chemistry deals with the study of the origin, transport, reactions, effects and fates of chemical species in the environment. The most important aspect of environmental chemistry which is prevailing nowadays and you are most aware of that, it is environmental pollution. Environmental pollution is the effect of undesirable changes in our surroundings. It has harmful effects on plants, animals and human beings. Any substance that causes pollution is called pollutant. Pollutants can be classified as solid, liquid or gaseous substances which are present in the greater concentration than in natural abundance. Sources of pollutants can be human activities or natural happenings. Small amount of pollutants in the air becomes significant as compared to similar levels present in the food, as an average human being, which is all of us, requires nearly 12 to 15 times more air than the food. Pollutants can be degradable like discarded vegetables which rapidly break down by natural processes. On the other hand, pollutants which are slowly degradable remain in the environment in an unchanged form for many decades. For example, substances such as dichloro-diphenyl trichloroethane known as DDT, which is banned nowadays, and plastic materials, heavy metals, many chemicals and nuclear waste, etc. These are the examples of non-biodegradable substances. These pollutants cannot be degraded by natural processes and are very harmful to living organisms. Environmental pollution occurs in different forms, that can be atmospheric pollution, water pollution, soil pollution, radioactive pollution, noise pollution, heat or thermal pollution and even light pollution. I will talk about atmospheric pollution in detail. The atmosphere that surrounds the earth is having different thickness at all heights. These are concentric layers of air and each layer has different density. Now let us discuss gaseous air pollutants. First pollutant is oxides of sulfur. Coal and oil contains sulfur impurities. When we burn these fuels, the sulfur in fuel also burns to form oxides of sulfur. The most common oxide of sulfur is sulfur dioxide gas, that is SO2. Sulfur dioxide gas is very poisonous to both animals and plants. Even low concentration of sulfur dioxide causes respiratory disease, example asthma, bronchitis, emphysema in human beings. Sulfur dioxide causes irritation to the eyes, resulting in tears and redness. High concentration of SO2 or sulfur dioxide leads to stiffness of flower buds, which eventually fall off from plants. Sulfur dioxide slowly forms sulfur trioxide in the presence of particulate matter in polluted air. What is sulfur trioxide? That is the oxidation product of sulfur dioxide to sulfur trioxide. The reaction you can see on the screen. The reaction can also be promoted by ozone and hydrogen peroxide also. That is SO2 plus O3 giving SO3 plus O2, or SO2 plus H2O2, that is hydrogen peroxide giving sulfuric acid, that is H2SO4. Next is oxides of nitrogen. Dinitrogen and dioxygen, which are the main constituents of air, do not react with each other at a normal temperature, but at higher altitudes where lightning strikes, dinitrogen and dioxygen combine to form oxides of nitrogen. NO2 is oxidized to nitrate ion, that is NO3-, which is washed into the soil where it serves as a fertilizer. In an automobile engine at higher temperature, when fossil fuel is burnt, dinitrogen and dioxygen combine to yield significant quantities of nitric oxide, that is NO, and nitrogen dioxide, that is NO2. The reaction can be represented as shown on your screen, that is N2 plus O2 reacting at higher temperature giving NO. This NO further reacts instantly with oxygen to give NO2. Rate of production of NO2 is faster when nitric oxide reacts with ozone in the stratosphere layer, that is NO plus O3 giving NO2 plus O2. Now I will discuss about environmental impact of nitrogen dioxide. In the traffic and congested places, the irritant red haze is due to oxides of nitrogen. Higher concentrations of NO2 damage the leaves of the plant and retard the rate of photosynthesis. Nitrogen dioxide is a lung irritant also that can lead to acute respiratory disease in children. Nitrogen dioxide is toxic to living tissues also. It is also harmful to various textile fibers and metals. Now, the environmental impacts of NO2 you can see on your screen. Now, let's discuss about hydrocarbons. Hydrocarbons are composed of hydrogen and carbon only. These are formed by incomplete combustion of fuel used in automobiles. Hydrocarbons are carcinogenic, means they cause cancer. They harm plants by causing aging, breaking down of tissues, shedding of leaves, flowers as well as twigs. Another class of gaseous pollutant is oxides of carbon, that is CO and CO2. First we will study about carbon monoxide, that is CO. Carbon monoxide is one of the most serious air pollutant. It is a colorless and odorless gas. It is highly poisonous to living beings as it has the ability to block the delivery of oxygen to the organs and tissues. It is produced as a result of incomplete combustion of carbon. CO is also produced by incomplete combustion of coal, firewood, petrol, etc. The number of vehicles has been increasing over the years all over the world. Most of the vehicles are poorly maintained, resulting in the release of greater amount of carbon monoxide, carbon dioxide and other polluting gases. Now let us understand why carbon monoxide is poisonous. CO binds to hemoglobin by replacing oxygen and binding itself with iron to form carboxyhemoglobin that you can see on the screen. Carboxyhemoglobin is about 300 times more stable than the oxygen hemoglobin complex. When the concentration of carboxyhemoglobin reaches about 3 to 4% in blood, the oxygen carrying capacity of blood is greatly reduced. Thus, there is oxygen deficiency resulting into headache, weak eyesight, nervousness and cardiovascular disorder. This is the reason why people are advised not to smoke. In pregnant women who have the habit of smoking, the increased CO level in blood may induce premature birth, spontaneous abortions and deformed babies. Now we will talk about carbon dioxide. Carbon dioxide is released into the atmosphere by respiration, burning of fossil fuels for energy, decomposition of limestone. It is confined to troposphere layer only. Normally it forms about 0.03% of volume by the atmosphere. With the increased use of fossil fuels, a large amount of CO2 gets released into the atmosphere. Excess of CO2 in the air is removed by green plants by the process of photosynthesis, and this maintains an appropriate level of CO2 in the atmosphere. As you know, deforestation and burning of fossil fuel increase the CO2 level and disturb the balance in the atmosphere. The increased amount of CO2 in the air is mainly responsible for global warming. Now dear students, we will discuss about global warming and greenhouse effect. About 75% of the solar energy reaching the earth is absorbed by the earth's surface, which increases its temperature. The rest of the heat radiates back to the atmosphere. Some of the heat is trapped by gases such as carbon dioxide, methane, ozone, chlorofluorocarbon compounds known as CFCs, and water vapor in the atmosphere. This you can see in the figure on your screen. Thus they add to the heating of the atmosphere. This causes global warming. Carbon dioxide is the major contributor to global warming. Besides carbon dioxide, other greenhouse gases are methane, water vapor, nitrous oxide, CFCs, chlorofluorocarbons which we called as, and ozone. Methane is produced naturally when vegetation is burnt, digested or rotated in the absence of oxygen. Large amounts of methane are released in paddy fields, coal mines, from rotting garbage dumps and by fossil fuels. And chlorofluorocarbons are man-made industrial chemicals used in air conditioning, etc. CFCs are also damaging the ozone layer. And what about nitrous oxide? Nitrous oxide occurs naturally in the environment. In recent years, quantities of greenhouse gases have increased significantly due to the use of chemical fertilizers and the burning of fossil fuels. If these trends continue, the average global temperature will increase to a level which may lead to melting of polar ice caps and flooding of low-lying areas all over the earth. Increase in the global temperature increases the incidence of infectious disease like dengue, malaria, yellow fever, sleeping sickness, etc. So it is very important to discuss about the factors that can reduce the amount of these poisonous gases in the atmosphere and hence can reduce the rate of global warming. But how can we reduce the rate of global warming? Let us discuss. If burning of fossil fuels, cutting down forests and trees add to greenhouse gases in the atmosphere, we must find ways to use these just efficiently and judicially. One of the simple things which we can do to reduce global warming is to minimize the use of automobiles. Depending upon the situation, one can use bicycle, public transport system or go for carpool. We should plant more trees to increase the green cover. Avoid burning of dry leaves, wood, etc. And it is illegal to smoke in public places and workplaces because it is harmful not only for the one who is smoking but also for the others, and therefore we should avoid it. Now let us discuss another very important topic, that is acid rain, its effects and causes. As we are aware that normally rainwater has a pH of 5.6. It is due to the presence of H plus ions which are formed by the reaction of rainwater with carbon dioxide present in the atmosphere. The reactions you can see on your screen. H2O plus CO2 giving H2CO3, H2CO3 giving H plus HCO3 minus. Acid rain is having pH below 5.6. Oxides of nitrogen and sulfur, which are acidic in nature, can be blown by wind along with solid particles in the atmosphere, and they finally get settled down either on the ground as dry deposition or in water, fog and snow as wet deposition. SO2 and NO2 after oxidation and reaction with water are major contributors to acid rain because polluted air usually contains particulate matter that catalyze the oxidation. This can be explained by the reaction shown on your screen. SO2 reacting with water and in the presence of oxygen giving sulfuric acid, and NO2 reacting with water and oxygen giving nitric acid. Now we will see what are the harmful effects of acid rain. Acid rain is harmful for agriculture, trees and plants as it dissolves and washes away nutrients needed for their growth. Acid rain causes respiratory ailments in human beings and animals. When acid rain falls and flows as groundwater to reach rivers, lakes, etc. Acid rain affects plants and animal life in aquatic ecosystem. Acid rain corrodes water pipes resulting in the leaching of heavy metals such as iron, lead and copper into the drinking water as well. It damages buildings and other structures also made of stone or metal. The Taj Mahal in India has been affected by acid rain, and it is a perfect example to see the adverse effect of acid rain. Acid rain reacts with marble, means calcium carbonate of Taj Mahal, causing damage to this wonderful monument that has attracted people from around the world. Now, what is the reaction which is occurring between acid rain and calcium carbonate? That is calcium carbonate plus sulfuric acid giving calcium sulfate, that is CaSO4 plus H2O plus CO2. Acid rain can be understood by watching this video. Let's now move on to another category of tropospheric pollutants, that is particulate pollutants. Particulate pollutants are the minute solid particles or liquid droplets in air. Sources of particulate pollutants are vehicle emissions, smoke particles from fires, dust particles, and ashes from industries. Particulates in the atmosphere may be viable or non-viable. Viable particulates are bacteria, fungi, molds, algae, etc. They are minute living organisms that are dispersed in the atmosphere. Human beings are allergic to some of the fungi found in air. They can also cause plant disease. Non-viable particulates are smoke, dust, mist, and fumes. Let us discuss all of these non-viable particulates in details. Smoke particulates consist of solid or mixture of solid and liquid particles formed during combustion of organic matter. Examples: cigarette smoke, smoke from burning of fossil fuels, etc. Dust. Dust is composed of fine solid particles which are over 1 micrometer in diameter, they are produced during crushing, grinding, and attribution of solid materials. Examples: sand, sawdust from woodworks, cement, and fly ashes from factories, dust storms, etc. Third is mist. Mist are produced by particles of spray liquids and by condensation of vapors in air. Examples: sulfuric acid mist, herbicides, and insecticides that miss their targets and travel through air and form mist. Last is fumes. Fumes are generally obtained by the condensation of vapors during sublimation, distillation, boiling, and several other chemical reactions. Examples are organic solvents, metals, and metallic oxides which form fume particles. The effect of particulate pollutants is largely dependent on the particle size. Airborne particles such as dust, fumes, mist, etc. are dangerous for human health. Particulate pollutants that are bigger than 5 microns can lodge in the nasal passage. However, particles of about 10 microns enter into lungs easily. Now I will talk about smoke. That is the most common example of air pollution that occurs in many cities throughout the world. The word smog is derived from smoke and fog. Two types of smog are classical smog and photochemical smog. Classical smog occurs in cool, humid climate. It is a mixture of smoke, fog, and sulfur dioxide. Chemically, it is a reducing mixture, so it is called as reducing smog. Photochemical smog, it occurs in warm, dry, and sunny climate. The main components of the photochemical smog result from the action of sunlight on unsaturated hydrocarbons and nitrogen oxides, which are produced by automobiles and factories. Photochemical smog has high concentration of oxidizing agents, so it is called as oxidizing smog. Now, how does photochemical smog form? When fossil fuels are burnt, a variety of pollutants are emitted into the Earth's troposphere. Two of the pollutants emitted are hydrocarbons and nitric oxide. When these pollutants build up to a sufficiently high levels, a chain reaction occurs from their interaction with sunlight, in which NO is converted into nitrogen dioxide. NO2 in turn absorbs energy from sunlight and breaks up into nitric oxide and free oxygen atom. Oxygen atoms are very reactive and combine with O2 in air to produce ozone, as you can see on the screen. The ozone formed in this reaction reacts rapidly with the NO gas, which are formed in the previous reaction to regenerate NO2, This is also shown on your screen. NO plus O3 gives NO2 plus O2. NO2 is a brown gas that at sufficiently high levels can contribute to haze. Ozone. Ozone is a toxic gas. Both NO2 and O3 are strong oxidizing agents. NO2 and O3 can react with the unburnt hydrocarbons in the polluted air to produce chemicals such as formaldehyde, acrolein and peroxyacetyl nitrate called as PAN. Now, what are the effects of photochemical smog? As we have just discussed that common components of photochemical smog are ozone, nitric oxide, acrolein, formaldehyde and peroxyacetyl nitrate, which is called as PAN. Photochemical smog causes serious health problems. Both ozone and PAN act as powerful eye irritants. Ozone and nitric oxide irritate the nose and throat. Higher concentration of ozone and nitric oxide causes headache, chest pain, dryness of throat, cough and difficulty in breathing. Photochemical smog leads to cracking of rubber and extensive damage to plant life. It also causes corrosion of metals, stones, building materials, rubber and painted surfaces. But how we can control photochemical smog? If we can control the primary precursors of photochemical smog such as NO2 and hydrocarbons, the secondary precursors such as ozone and PAN, the photochemical smog will automatically be reduced. Usually, catalytic converters are used in the automobiles, which prevent the release of nitrogen oxide and hydrocarbons to the atmosphere. Certain plants, example pinus, juniperus, curcus, pyrus and vitis, can metabolize nitrogen oxide and therefore their plantation could help in this matter. Dear students, so we have learned how pollution is deteriorating the environment. So it is a request to all to take the preventive measures for controlling it, as nature belongs to all and it is our duty to preserve it. We will be discussing about water pollution and strategies adopted to control environmental pollution. Be safe and keep high spirit of learning. Thank you.